Understanding the effects of oscillation and bifurcation in thermocapillary convection is important for the study of strong nonlinear flow in space.
Due to limited space resources and conditions, the experimental payload should be small in size, light in weight, and possess anti-vibration abilities.
Space technology breakthroughs such as performing liquid surface maintenance and liquid injection without bubbles can further enhance the technical capacity of microgravity experiments in fluid physics.
Observing the convection transition, temperature oscillation, and the surface deformation of a liquid requires the use of thermocouples, an infrared thermal camera, and a displacement sensor.
Demonstrating the procedure will be Wang, Wu Di, and Wu Liang, technicians from my laboratory.
Begin by constructing a copper annular liquid pool with an inner radius of 4 millimeters in diameter and an outer radius of 20 millimeters in diameter and a height of 12 millimeters. Use a 20 millimeter diameter polysulfone plate as the bottom of the liquid pool and drill a small 2 millimeter diameter hole 6 millimeters away from the center of the plate as the liquid injection hole. Add sharp 45-degree angle corners on the inner and outer sidewalls, and apply anti-creeping liquid to the inner and outer walls to a height greater than 12 millimeters. Next, select an appropriate low-viscosity silicone oil as the working fluid.